Hello students, today we will discuss about construction of a burial history curve. Hopefully you have gone through your previous lectures, particularly on source rock evaluation, where I gave a brief introduction about burial history curves and their uses. And before doing this lab, let's refresh yourself about burial history curve first. You can go through your lectures. You can also read some stuff online or from your book regarding burial history curve and its application. Okay, let's start um, to learn how we can construct a burial history curve. First of all, what type of data actually we need, and that is mostly the well data. Here is an example of well data. This was a well which was drilled somewhere, I think, in North Sea or somewhere else. And in most of time, we got formation name, as you can see in left column here, and then bottom depth and its age, and then you can calculate thickness as well. And by using this data, you can construct a burial history curve. Sometime you obtain the top depth interval or top of these formations, then you have to extract the bottom of those formation as well from that information. So I will also explain how you can get bottom of a particular formation if you have a top of that formation. Similarly, you also have to convert your geological age into number. Uh, just like if it is Jurassic, then in what number it's fall, or if it is Cretaceous, what that means, how many million years. Similarly, you also have to calculate the thickness of a particular formation which was encountered during drilling of your well. So this is very basic data, and mostly this data is easily available for the drilling wells, and by using this data set you can construct a burial history curve. And this data set actually available online, and Dr. Jamal from Malaysia actually have given a detailed presentation on this topic, and it is available online. If you can search Google, you can get this data and also some other useful stuff from his presentation as well. And most of the stuff in this lecture I have taken from his presentation that I found very effective and easy to understand. So let's discuss about the construction. Okay, first of all, as you can see at the right top corner, if I want to build a burial history curve of a particular formation, this is TC, it is one formation, and it was deposited about 65 million years ago. And today its total depth is around 2043 meter. And at 65 million years, actually it was at zero depth, and then it's going to increase its depth by the addition of sediments at the top of this formation. And this actually means the burial, how much burial actually accumulated at the top of this formation. And we will use time stratigraphy data for constructing burial history curve, and also we will locate starting and end points, and then we will identify the events or the time of burial from same data set. And let's look at this first point that actually representing the point 65 million years ago when this formation just start deposit, or you can say the sediments are going to accumulate. As you can see, this point representing this bottom point here, 65 million years ago, when this formation was just going to start to deposit. And the other point is when this is the today's time, as you can see, it's a 0 million years. And today, its depth is around 2043 meters. So we will plot all other information that fall in between these 2 points. Okay, first of all, it's very important to understand this point, how we got this information from well data. As you can see on the left side, the bottom depth of this TC formation is around 2043 meter. Okay, and this is present day depth. So I have to create an additional column where I will mention these depth according to the requirements or according to the requirement of burial history curve. I mentioned this depth at the zero time, and about 65 million years ago, I assume that this formation was just going to start to deposit, so I take zero as the depth at that time. So both of these points actually are coming from well data, and again I am going to mention it is a bottom depth, not the top depth. So please also focus on the type of data you are using. We are using the bottom depth of this formation, and this is its starting point about 65 million years ago. And this 65 actually is coming from here. That is the same the formation age. Okay, now let's see how we will plot the points in between these starting and end points. Okay, now let's see. This is important how you will proceed from at the bottom of the table to the top. And for next point, I have to look how much thickness for this formation actually deposited during this interval from 65 to 49. And if we go back to the table, as you can see, this formation actually deposited about 609 meter, means its thickness was this one. And I will just mention the 609 meter here because during this interval from 65, starting from 65 and ending up to 49 million years, and the total thickness of deposition was 609 meter. I will just mention this thickness in the front of other formation in the table. And this interval actually representing the thickness of this formation that deposited in this interval. And how we can plot this point on the graph, as you can see, actually it was deposited at 49 million years point, and you can also interpret like this: it was deposited from 65 to 49. And how much thickness? Around 609. So 609 is on the y-axis, actually it's a depth interval, and on x-axis it's around 49, which falls somewhere here. And you can also explain in other way like this. At the 65, the thickness of TC formation was 0 meter, and as the age going to decrease or the time passes, the thickness of this formation is going to increase, and up to 49 million years when another formation is going to start, but this formation was going to end. So this is the way we will plot this point here. Okay, and similarly, you will follow the same scheme and reach up to the bottom of this formation. As you can follow this table, in the next point, you will add both thicknesses 609 and 341 because up to 22 million years, this formation was actually deposited and total thickness was around 905. And here, similar, this point is plotted here. Similarly, the other points and detailed calculations are given here. And it's very simple process. You just have to add up the additional layers, and these additional layers mean you are adding the material on the top of this formation, and you are going to reach up to the today's thickness or today's depth of this formation. And it will give you a burial history curve, means how this formation is going to bury. And hopefully, if you go through these calculations, you can easily understand how we are going to add different layers on the top of this particular formation. And this single curve actually only representing this single formation. We can also say this is a burial history curve for TC formation. It's actually representing how this formation starts 65 million years ago at this point. Then, after passing few million years, this much material was deposited on the top of this TC formation, and then after passing more time, and this much material was deposited, and similarly going on, and then you reach up to today's depth, and today it's around at 2043 meter in the subsurface. So this is the way we can plot burial history curve for all these formations separately. Okay, here I have provided the detailed plot as well. As you can see, this pink color actually representing the TC that we just observed in detail in our last slide. And for other formation, you will follow the same process and you can get these curves as well. And these curves actually are called burial history curve for different formation that was actually encountered in your well. And there are a number of applications of these burial history plot. And in later stages, you can add the temperature data on this graph as well. You can add straight line if you know the temperature gradient. You can add the straight line. Then you can interpret the which formation passes what time interval or what temperature interval during its deposition. So that's also another task, but in this lab we will only focus to learn how to plot these curves by using the well data. Okay. Okay, here is your main task for lab 4. What I have provided you, I am going to give you well X. It was actually drilled in somewhere in Pakistan, and here are different formations. Those were encountered in this well, and this column MYA mean million years ago. For your convenience, I just converted those ages into numbers so that you can just use these numbers to plot the data. Similarly, I also provided the top depth or the top of the formation. Actually, this information mostly available in most of data sets. So you have to get the bottom depth. So that's not a tough task. How? Actually, the top depth or top of aluminum is 0 meter and bottom is 80 meter, and 80 is also the top of Sivalix next formation. Similarly, 750 is the bottom of 758 sorry is the bottom of Sivalix and top of Nummel Formation. Similarly, 982 is the bottom of Nummel Formation and top of Dungan Formation. So the same interpreted values I just put in the next column. Actually, these numbers are representing the bottom depth of these formations. So in the burial history plot, you have to use these bottom depth intervals. And similarly, you can calculate if you know the bottom and top of these interval, just subtract, you can get the thickness of a particular formation. Similarly, like this valley, if you subtract the 80 from 758, this is the top and this is the bottom of Svalix, and you can get from top and bottom the thickness of this formation. So after getting bottom depth and thickness of a particular formation, you can take this data into Excel and let's plot the burial history curve for a particular formation. And for your help and for understanding purpose, I just plot a one curve for you for salt range formation, as you can see here. Actually, basement was not drilled. This basement actually also representing the total depth of this well. And so we have to focus on the formation those are actually encountered and how much thickness we observe in that well. So by following the similar process as I explained in previous slides, you have to put the numbers of time in million years ago. Just put years ago as well here, and then take the particular formation. Let's suppose I take the SAR range, and it's actually the at Precambrian it was zero. It was going to deposit, and this point is plotted here around 565 million years ago. And then in the next up to 535, about 80 meter thickness or 80 meter interval was deposited, and this was actually the SAR range formation. Similarly, you will add this one in the next thickness, and the thickness value over here, and it will be 785. And similar process you will follow, and you will reach up to the bottom depth. Today's bottom depth of this SAR range formation, that is actually the 2863 meter, and that actually in today's the here you can see the depth is around 2863 meter at 0 million years ago, and this is you can say present day. So let's take other formation and generate additional columns here and take this data into Excel. Actually, I provide the image of this data set, and I want you yourself generate these table in Excel so that you can take the real feeling of interpreting the petroleum industry data and how the geologists and even some engineers also plot these burial curves to understand the reservoir as well as source rocks. And the one additional component that I provided at the right top corner, that actually the temperature gradient in this area, and this is around 0.05 centigrade per meter, means at 500 meter depth your temperature will be around 25 centigrade here. And similarly 50, and then 100, 150, 200, and these actually are the subsurface temperature. This temperature gradient was calculated from log, but it will really explain in your coming subjects or maybe next semester when you will study well logging subject, and in that subject we will learn how this temperature is actually measured in the well. So at this point just use this data and assess how temperature is going to vary in your well with depth. And then you can also plot here the horizontal line for particular temperature. For example, at this 2000 meter depth, the temperature 100 centigrade. Yeah, 25, it will be around 100, and yeah, it's 100, and then here it's around 125, and one. And also I will recommend also go through your lecture notes as well, where you can study how with the increase of temperature your source rock is going to mature, and how these burial history curves can be used for interpreting the majority of source rock. That was also the part of your lecture. So you can go there and read again the application of these curves. And at the last, I also want to show you the software-based interpretation of these curves and software-based diagram. And this actually was developed in a software, industry-based software. And unfortunately, presently we do not have license for that. and actually it was developed in Canada by using a licensed software from the industry. But you can just feel how when we put the data in the software, how different things we can do that may not be possible in Excel. Just like the subsidence as well as these color variation of temperatures and the filling of lithologies. And these are additional, you can say, advantages of using some advanced software for developing burial history curves. And here are ages, and on y-axis there is a depth interval as well. So I will see if I can get some software for you. We will also learn their software to develop the same burial history curve. But before that, it is very important that you should have basic idea to develop a burial history curve, how to perform some basic calculation, how to understand those technicalities that are actually involved in those data sets. So let's put some effort on plotting the burial history curve for all these formations, and also put this temperature data as well. You can just plot horizontal lines on this diagram for temperature lines, and then let's give some basic interpretation based on your curves. And I will wait for your final lab report, and I am also curious how you will interpret and how you will add some innovation in these plots, and that will also define your grades as well. So okay, let's try this lab, and if you feel any difficulty or if you still feel any confusion, you can call me or you can email me, or even you can give me some messages on WhatsApp as well for further explanation. Okay, thank you and bye.